And now, broadcast live in front of a live studio audience for the first time from the certified up-to-code WYZT studio, it's the Corny Collins Miss Hairspray Spectacular.
He's corny.
Brought to you by Ultra Clutch Hairspray. What gives a girl power and punch? Is it charm? Is it poise? No, it's hairspray.
The entire structure of hair has 4 parts. The follicle, the portion of a strand of hair below the skin. The cuticle, the portion above scalp level. The cortex, which lies within the cuticle. And the medulla, a canal that contains air within the cortex. Hair is made of protein which originates in the hair follicle. As the cells mature, they fill up with a fibrous protein called keratin. The keratin found in hair is called hard keratin. This type of keratin does not dissolve in water and is quite resilient. One of the main components of hairspray is polyvinyl acetate, also known as PVA. The key property that makes this polymer useful as a hair holding agent is its ability to form films upon drying. Once hairspray is applied to the hair, the liquid drops run down the hair shaft until they reach the intersection of 2 hair fibers. When the drops dry at this fiber intersection, they create an invisible film that bonds hairs together. Before we explain how our homemade hairspray works, do note that the R group which reacts with our hairspray is aspartic acid. The adhesive force that binds the hair together is the electrostatic force of attraction between cation and anion. The chemical involved are cationic polysaccharide and negatively charged protein. For our sugar hairspray, when aspartic acid dissolves in water, the carboxylic group, which is acidic, tends to lose a proton, and the amine group, which is basic, tends to gain a proton. Next, we know that table sugar is commonly made of sucrose, which is a type of polysaccharide. Sucrose is a neutral polar molecule. Hence, when it dissolves in water, the bond between the oxygen and hydrogen atoms gives the oxygen a partial negative charge and the hydrogen a partial positive charge. An ion dipole force then occurs. An ion dipole force is an attraction force that results from the electrostatic attraction between an ion and a neutral molecule that has a dipole. In this reaction, the positive ion of aspartic acid, which is NH3+, attracts the partially negative end of O2- of sucrose. At the same time, the negative ion of aspartic acid, which is OH-, attracts the partially positive end of a neutral polar molecule. This attraction force helps to bind the hair together. For our orange hairspray, pectin, a structural heteropolysaccharide, is found. The same reaction occurs. Through our observations, we find that the electrostatic attraction force between cationic pectin and protein is stronger than the attraction force between sugar and protein. This is because while 4 OH bond from sucrose can react with aspartic acid, 5 OH bond from pectin can react with aspartic acid. Since aspartic acid is considered to be in excess and a higher number of moles of OH bond can react for pectin, the attraction force will be stronger for the reaction between pectin and an aspartic acid.